Hello, amazing students. Consider this the answer key to the Chapter 3 closure level problems. We're going to go over some details that will hopefully help you prepare even better for any upcoming assessments and also just to get better at math, hopefully. Hopefully you can learn a couple tricks as I go over these problems here. So we're going to start off with problem number CL closure 3124, where it says to solve for x, showing all work. So again, our goal for today, for this video, is to go over all of these problems here. And if there is some time, I will also be going over a couple of problems for solving. Okay, so here we go. Starting off with solve for x. Check your work. This is top left page of the closure levels worksheets. So the first thing that I'm going to notice about letter A is that we do have some like terms. So right away, I'm not going to solve anything. I'm not going to move anything around. All I'm going to do is I'm going to combine these two like terms. 6 minus 3 happens to be 3. And then everything else stays the same. Okay, notice how this difficult problem became a little bit easier when all I did was combine like terms. Now, this is where I would like to move things around until I get my answer. Of course, my goal is x equals something. So typically we have x on the left side of the equation, which is the variable on the left side. And then typically we have numbers on the right side of the equation, which is our constant, or hopefully our answer. In this case, we do have a negative x and a positive x, but the negative x is on the left side. So this is kind of strange because if I did minus 4x, don't write this down. If I did minus 4x, that would become negative. I don't want negatives. Most people in math tend to avoid negatives because they can make for mistakes, more mistakes than we anticipate. So what I'm going to do is I'm going to decide to move the x, the negative x, to the right side. Anytime I do the opposite, which is a zero pair, negative x and positive x, for example, I'm going to cross it off, but also do the same on the right side of the equation. Okay? While I'm at it, I'm going to do a zero pair for the negative 12. Since I want the x's on one side, I'm going to move the negative 12 to the other side. That's a zero pair, so I like to cross it off. Okay, now what we have is, and I love to see it vertically, once it's crossed off, you can, don't do that, but you can see what is left when we cross it off. We have such an easy problem on the left side. You see that? It's one of the easiest problems we can have in math is an addition problem without any variables. So 3 plus 12, I know that is going to be 15. And then 4x plus x, we know that is 5x. It's like saying 4 apples plus 1 apple is 5 apples. Okay, so next step, of course, we need to do the inverse operations to get x by itself. Opposite or inverse of add is subtract. Opposite of multiply is, what is it? Yeah, divide. And I'm not going to use an x anymore for multiply. I'm going to use a dot for multiply and a division sign because those are opposites. So since I have 5 times x, I'm going to do the inverse of multiply by 5, and I'm going to divide by 5. Right? If you ever had to find like 5 times something is 15. 5 times what is 15? Instead of guessing, 5 times 2, 5 times 3, 5 times 4, instead of guessing 5 times what is 15, just divide by 5. 15 divided by 5 gives us the answer, and that is the correct answer for letter A. Okay, Next up is a slightly more difficult question. You can look at it and see, oh, that is a little bit more difficult than I anticipated. But there are a couple of things that you might want to notice about B. There isn't always an answer of x equals a number. What if there wasn't an answer? Do you remember the other types of solutions that we might have? Well, let's go over it. So again, first thing I'm going to do is I'm not going to move anything around left or right. I'm going to see if I can combine any like terms. So for letter B, on my left side, I have negative 4x minus 39. On my right side, I have a lot more. I know I can definitely combine some like terms here. So I'm going to do 2x and negative 6x, 2x minus 6x. I like to say it like this. If you have 2 apples and you owe me 6 apples, you have 2 apples and you owe me 6, then you might only owe me 4 after that. So what happens if you combine 2x minus 6x? Yeah, you'll get negative 4, which means you owe me 4. All right, now the other term that I have here is saying negative 19 and negative 20. Yeah, it does say minus, you're right. Negative 19 and negative 20 are the same as minus 19 minus 20. It says you owe me 19, you owe me 20 more. So if you owe me $19 and $20 together, you would owe me, that's right, $39. And I'm going to write the rest of the equation the same. Now here's the thing. You might notice something weird. Left side and right side of the equation are what? Yeah, they're the same. So there's going to be a special situation here. So I'm going to do something. It might be a little bit different than the way you do, and that's fine. I'm going to move 4x, or negative 4x, sorry, to the other side, but that's going to cross it off. And I'm going to get negative 39 equals negative 39. I notice some people also cross these off. Since they're balanced on the left side and the right side of the equation, if you added 39 and added 39, you would alternatively get 0 equals 0. Well, here's the thing. Does 0 always equal 0? Or does 0 never equal 0? Yeah, because here's the thing. If it's always, we're going to say infinitely many solutions, or for short, infinite solutions. If it's never, alternatively never, then it's going to be no solution. So this is a little bit of a good thing to have in our notes. If it's always true, it's called infinite. If it's never true, it's called no solution. Okay? Well, question for you. Does 0 always equal 0? Yeah. Does negative 39 always equal negative 39? Yes. So we're going to therefore say, this is the therefore symbol, that the answer is, and I'll write it out this time. You can definitely write it out if you want to, infinitely many solutions. I know some people like to say just infinity, but the answer is not the idea of infinity. The answer is that any number that I put in for x, it's going to be the same on the left and right side. If I put in 10 on the left and the right side, they would be balanced. If I put in 5 for x, they would be balanced. And you can show that. But we're going to move on. I hope that helped. All right, problem number 125 says to create an XY table from the points on the graph at right or below here. then write a rule for the table. So the first thing I do want to note or notice is if it is a straight line, which it is, you don't have to add a straight line. The rule is going to be y equals mx plus b, where m, we're going to keep it simple, m is the growth, and b is the start. Okay, we can go into more detail, but for right now, that's pretty much the two things you need to know is you need to have two things for your equation, your rule. Okay? So I've noticed I did this table earlier and my table didn't fit on this space provided here. So I'm going to give myself a little bit more room. Okay, so if you correctly named each of these coordinates, the leftmost x value, which is the x coordinate here, it goes left 2, and then for the y coordinate, it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9. That coordinate right there is -2, -9. Now, if you do the same, you'll get -1, comma, what? -1, 2, 3, 4, 5, 6, 7, right above 8. Sorry, right above -8 is -7. If you do this carefully, you're going to notice that you have a really awesome pattern of growth. 0, comma, let's see what it is, 0, comma, -4. Okay. Oh, did I mess that up? I totally messed that up. How did I know that I messed that up? Here's the thing. Does that pattern show consistency right there? No, it goes up by 2, then it goes up by 3. That's not good. I messed it up. So that coordinate that I made a mistake on was actually 0, comma, -5. Yeah, if you put 0, comma, -5, you got the right answer. Nicely done. Okay, next up is going to be this coordinate right here. 1, comma, -3. Goes right 1, down 3. 2, comma, -1 is this one right there. We have 3, which is right 3, up 1. 3, comma, 1. 4, comma, not quite 4, comma, 4, right? 4, comma, 4 would be right there. This one's 4, comma, 3, and then of course we have 5, comma, 5, and 6, comma, 7. Okay, those are the correct coordinates. You didn't have to have all of them, but we did have to have most of them. Okay, now, what's the rule? What's your growth? What's it growing up by? What's the slope? Another way to say growth is slope. The growth is going to be represented by the letter M. It's also, what's your rate of change? What's it going up by every time? If you notice, it's going up by 2 every time. That's because the correct answer is 2. The growth in this table is going to be 2. So I notice a lot of people on their tests say, hey, the rule is going to be add 2. No, do not say add 2. You have to tell me, where did you start? For example, if you said you're going up by 2 million every day, $2 million every day, I'll say, yo, that is amazing. That is awesome if you're going up by 2 million every day. But when did you start? Where did you start? Did you start with $1 million in debt? You have to be more specific than just add 2. So that's why every equation is going to have not only a growth, but also a starting value. Now the start is wherever your 0 is. The y-axis tells you, I messed that up. The y-axis tells you where your graph starts. Yeah, it doesn't start left of the graph. It starts right on this y-axis here. Let me see if I can label it. Right there. Wherever it crosses that y-axis is going to be the start. So if you look at the graph, you'll notice that it's 0, comma, -5. Or just -5. Okay, it says now make your graph a complete graph. I think I might have forgotten this one. So the two things that we really wanted to do or add onto this is we already have the x and y labeled. That's great. We already have the scale labeled. That's awesome. We just need to add a line that extends all the way across my graph. So let me erase here a couple of things. And I need to make sure I add a line that extends all the way through my graph. I need to have arrows. And I need to write the equation on my line here. Y equals 2x minus 5. There's one more thing. That's why we have toolkit page 24 to help us out during our quiz, right? The last thing I should note is that the y-intercept is 0, -5. As a matter of fact, I can write this down as y-intercept. The y-intercept is shown on the graph as 0, -5. You might wonder, why is that an important thing? Yeah, not trying to draw a pumpkin, happy Halloween, but it's because the y-intercept is the same thing as the start. Okay? All right, that one's complete. Now, let's go on to number 121. Hopefully you had no questions and that everything was clear. Okay, for number 121, we're going to start off with the distributive property. Of course, the distributive property, you can write this in your notes if you don't have it yet. I think we did a page on this, I think it was page 21. Distributive property means if we have A times B plus C, we can do something called distribute. Everything that A includes needs to multiply by B, and everything that A includes also needs to multiply by C wherever the parentheses ends. So for this situation, there's actually a little bit of an interesting one going on here. We have a negative sign, just a negative sign. There's nothing after the negative sign. It's not -2 or anything. But what I want to do is I want to distribute the negative sign. Did you hear that? Distribute the what? Yeah, distribute the negative sign. So I'm going to rewrite this section right here as -2xy. And then a negative times a positive is -2x squared. And then everything else just needs to stay the same. So since I have the same thing here, 3x squared stays the same. -5x. I'm going to write it carefully because I don't want to write this incorrectly at such an important step here with so many terms. Okay. All right, I want to go ahead now and combine like terms. I'm going to notice that I have 3x squared and -2x squared. I'm also going to notice that I have let me use a different color here, xy and a -2xy. Nothing else are considered like terms. So I'm going to combine the ones that I have in red. 3x squared minus 2x squared is like saying 3 bananas minus 2 bananas. If I combine those bananas, I will get only 1 banana. These two terms stay the same. And then we have xy minus 2xy. That's like saying 1 chicken nugget minus 2 chicken nuggets. 1 chicken nugget minus 2 chicken nuggets is negative 1 chicken nugget. I don't have to say negative 1 chicken nugget. I can just call it a negative xy. And since I don't have any like terms there, I can consider that problem done. Letter A at least, the first part. The second part actually asks me to use x values and y values in this equation that I just formed. So step 1, I'm going to write down the problem here. And step 2, I'm going to substitute wherever x is, I'm going to substitute negative 1 with parentheses. And wherever y is, I'm going to substitute 6 with parentheses. Okay? So I have x squared. I'm going to write negative 1 squared. Minus 5 times x. Well, x is, again, negative 1. Minus 4. That's pretty chill. Minus x. Again, we're using x so much in this problem. And it's negative x times y. So y is 6. And I'm going to use parentheses there. All right, again, just double check that everything sounds correct. It looks correct. I think the xy became negative 1 times 6 because what does xy mean? X plus y, x minus y? No. Yeah, xy means x times y. Okay, so now we're going to evaluate this. Negative 1 squared is 1. Negative 5 times negative 1 is positive 5. Negative 4 stays the same. We have two negatives here. Negative 1 times 6. So that's going to be positive 6. Okay, now adding up everything correctly, we're going to get 6 minus 4 is 2. 2 plus 6 is 8. And that would be the correct answer. Let's move on. Okay, I'm going to give you a chance to write that down. You can always pause the video if you're watching this at a later time. And we're going to move forward here. Okay, draw figure 0 and figure 4. So the pattern that I noticed for this situation here, you probably saw it as well, was that this middle section right there of figure 1 just kind of stays on the left. And what they're doing, and I'm going to use the same color for growth, is I'm going to notice that they keep adding 2 and 2 more and 2 more. So how would I be able to draw figure 0? Figure 0 is the same thing as my start. So figure 0 would be 2, well, let's just write it this way. It's adding 2 every time, right? It's adding 2 every time. If I keep going right, it's adding 2 and adding 2 more. So if I go backwards, I'm going to need to subtract 2. If I get rid of these 2 pieces, I'm only left with 1. So if you got that right, that's awesome. Nicely done. Figure 0, which is considered my start. My start is equal to 1 tile. You can kind of notice that. Okay, the second thing I'm going to notice is the growth is equal to 2. I guess you could say tiles there, 2 tiles per figure number. Okay, so now that means if I were to, I'm going to see if I can do something here. Can I copy this image? Oh, that's awesome. So if I am able to just add 2 more tiles here, it would look something like that for figure 4. Okay, what's the equation? Don't say adds 2. That's not the rule. You have to say it adds 2 but starts at 1. Okay? In other words, I'm going to say that the growth is 2 every x tile. 2 times. It's growing at 2 times. 2 every time. But it also needs to start at 1. Okay, again, I'm going to just quickly highlight a couple of things here that, what do I need to highlight? Oh yeah, the growth is 2. I highlighted that in red here. All right, the growth is 2, which is right there. And the start is 1, which is always the amount of tiles in figure 0. Okay, I'm going to try to up the pace, but still try to learn something from this part. If you haven't learned anything so far, this is where problems do become a little bit unfamiliar. So it says for letter 2B, you can do this one. Letter 2C is a little more difficult, but it says using the rule that we just came up with, 2x plus 1, how many tiles will figure 50 have? So x is just the figure number. If I put in 50 for x and add 1, I will get 101 tiles. Using your rule, which figure number will have 27 tiles? So you can take your equation, 2x plus 1, and kind of guess and check. You can be like, oh, is it figure 13? Is it figure 22? What number would it make sense to get 27 out? Otherwise, put 27 in for y. If 27 is your desired outcome, put 27 in for y, because y is the number of tiles. All right, solving this equation, I'm going to get, if I subtract 1 and then divide by 2, I will get 26 equals 2x. I think I was a little bit ahead of myself there. Dividing by 2 now, we're going to get x equals 13. So figure number 13. Which figure number will have 27 tiles? I'm going to more specifically say figure 13 will have 27 tiles. Now double check. Does 13 times 2 plus 1 equal 27? Yes, it does. So we got the right answer. Okay, practicing that idea, we're going to practice this idea a little bit more because this idea can definitely seem new for a while until you've practiced it a ton. So we're going to try to practice it even more. All right, problem number 119. Let's read it here. 1 year ago, Josie moved into a new house and noticed a beautiful vine. That's awesome. Growing on the back fence. She recorded the data in the table below. We have x, which is weeks, y, which is the height. Oh, it says in inches. Cool. Okay, got it. Assume the vine continues to grow at a constant rate as you answer the question. Okay, cool. So that means it's growing in a straight line, at least the same amount of growth every year. How tall was the vine 7 weeks after Josie moved in? I think this is kind of an easy question. Oh, it's question A. That's why it's the first question here. After 7 weeks, how much height would the vine have? Well, let's look at the pattern. what is it consistently adding every time? 16 plus 3? Yeah, 16 plus 3 makes sense. 19 plus 3 is 22. So if I add 3 more, I will get 25. How tall was the vine 7 weeks after Josie moved in? 25 specifically inches. And you can say tall if you want to as well. How tall was the vine 3 weeks after Josie moved in? Okay, let me use some color here. 3 weeks. If I go backwards and follow that pattern, I will be able to reach week 3. Okay, subtracting our growth, 16 minus 3, I hope you got that right, was 13 inches tall. That would be the correct answer. Okay, how tall was the vine when Josie moved in? Ooh, this is a good one. When Josie moved in is going to be the 0. So you can follow this pattern. You can say here, following the pattern of, I guess you can say, removing 3 inches or subtracting 3. We get to the number what? Let's see. Which number would we reach here if I kept subtracting 3? 13 minus 3 is 10. That's giving my second week there. 10 minus 3 is 7. That's giving my first week. But my starting week would be 4. That right there is when she moved in. So following the pattern of 3, of minus 3, we get 0, comma negative. Oh, I messed that up. 0, comma what? Yeah, 0, comma 4. So therefore, it was 4 inches tall. I'm going to write down a little note here. That's the start. Okay. Next up is letter D. Letter D is asking us to predict how tall the vine was 19 weeks after Josie moved into her house. So in this situation, we're going to use an equation. The equation here is going to be, I'm going to write it one more time if we missed it. M is going to be the growth. B is going to be the start. So what was the growth for this situation here? The growth was, 3. And the start was 4. Did I do that correctly? Let's see. It grows by 3. Good. Starts by 4. Okay, 0, comma 4. That makes sense. Okay. So now we're going to predict when the vine was 19 weeks. And that means we're going to plug that in for... Oh, is it plugging it in for X or is it for Y? Check this out. It says predict how tall the vine was 19 weeks after she moved into her house. 19 weeks is X. So we're going to go ahead and say Y equals 3 times 19 plus 4. I'm going to get a calculator out. 3 times 19 plus 4 gives us 61. So that is going to be equal to 61 inches tall. The next one is where it's asking us to predict when the vine reached the top of the garage, when it reached a height of 94 inches tall. I'm going to highlight this one in a different color. This one's the more difficult one. Okay, height of 94 inches tall. So what we do in this situation, we can either guess and check with our equation, or we can put that in for y. So 94 equals 3x plus 4, and solve. Okay, so 94 equals 3x plus 4. That means what number would we need to put in to get to an output of 94 inches tall? I'm going to subtract 4. That gives us 90 equals 3x. Dividing by 3, I get the answer of x equals 30. Or in this situation means, when did the vine reach the top of the garage? It was after 30 weeks. And that should be the correct answer. Hopefully I didn't make any mistakes in this video, and I tend to make at least one mistake there. But that will be the going over the closure problems. I hope that this video helped. I am going to do one more thing here, though. I'm going to go over 3 math problems. I know we needed some assistance with some of these problems, but the more you go over this stuff, the better. So I'm going to go over them now. This problem should look a little familiar. It looks a lot like these problems over here. They're very similar. So going back, how would I solve this? Again, the goal is to always get x equals something. Usually it's a number, but lately we've noticed that there might be infinite solutions, which is always, or there could be no solutions, which is the never situation. Okay. Again, this is a little bit of my way of memorizing how this works, so I hope that it helps you remember the difference between those two. A lot of students have trouble memorizing the difference between these two because they're unique, really. Okay, let's go ahead and solve this. For letter A, I'm only going to solve this one, which is version A, I believe, yeah. Version A of our quiz here. I'm going to add 12x to both sides. They both cross off. I'm left with 8 equals negative 4. Does 8 always or never equal negative 4? Is this statement true always, or is it never? Never, so I'm going to put a not equal sign, and I'm going to say no solution. I think it was a little strange to say x equals no solution, but I'm going to just go ahead and erase that part here and say the answer is no solution. Okay, you could have gone a little further if you wanted to go ahead and add 4, etc. to get the numbers balanced, but still, it wouldn't be possible to make those two numbers equal. Okay, the second one here, I believe this one might have one solution. Let's double check here. I'm going to get this x on the left side. I'm going to subtract 3x. 3x, that gives us... I'm going to do the same thing over here with the numbers. I'm going to move the numbers to the right side at the same time. It's just a little bit of a life hack. Get things on opposite sides. We're going to get 4x minus 3x is just x. 5 plus 7 is 12. That means there is one solution, which is 12. Okay, the last problem here. I always like to start with like terms. On the left side, there are no like terms. It's like saying 4 apples minus $5. They're different things. But on the right side, we do have like terms. So x plus 3x is 4x. And we have 4x minus 5. In this situation, we have 4x minus 5 equals 4x minus 5. You can ask yourself right now if you want to. Is this always equal, or is it never? Does 4x minus 5 always equals 4x minus 5? You can definitely think about it as a yes. But we can show a little more work if we'd like to. Subtracting 4x gets rid of the 4x's. And adding 5 if you want to as well. Gets rid of the 5's. We're left with 0 equals 0. Or you can even have negative 5 equals negative 5. Whatever was on your paper, hopefully you said that this is always. Our first problem in this situation was never. But does 0 always equal 0? Or does 0 never equal 0? 0 always equals 0. So we're going to say infinitely many solutions. Or for short, you can say infinite solutions. And that was the answer. I hope that this version helped. If you want me to go over or your teacher to go over a different version with you, go ahead and ask, and we would love to show you. All right, again, I hope this video has been extremely helpful for you, and I hope you have an amazing rest of your day. Goodbye, everyone.